Welcome to our statistics and probability class. Last time we were able to discuss the mean, variance, and standard deviation of a discrete probability distribution. This time we will show more examples on how to calculate and compute those. You will learn how to compute mean, variance, and standard deviation. Last meeting, we were able to discuss the formulas in getting the mean, variance, and standard deviation. So for this meeting, we will show examples. Suppose example number 1, let's consider this probability distribution with random variable x and values of 1, 2, and 3 with the probabilities for 1 of 0.46, for 2 0.21, and for 3 is 0.33. Let's start with the mean. So mean, denoted by mu, is actually the summation of x times p of x. So let's start. So we'll write mu is equal to, we'll have here 1 times 0.46, then plus 2 times 0.21, and plus 3 times 0.33. Again, the value times its probability, that's 1 times 0.46, and then 2 times 0.21, and 3 times 0.33. After multiplying these values, add them all and then you'll get your mean. So let's continue. Mean is equal to 1 times 0.46 is 0.46, plus 2 times 0.21 is 0.42, and then plus 3 times 0.33 is 0.99. Add them all, you'll have 0.46 plus 0.42 plus 0.99, you will get 1.87. Okay, so that's how you get your mean. Again, let me repeat. You multiply 1 with its probability. So you have 1, you have it here, times the probability, which is 0.46. This one. And then continue with the other values with its corresponding probability. Add them together, you'll get your mean. Alright? Okay, this time let's have another example. Consider this probability distribution, random variable x with values 0, 1, 2, and 3 with the corresponding probabilities. If you recall, you can tell whether a distribution is a discrete probability distribution when you add all the individual probabilities. You will get a sum of 1. Let's try. 1 over 10 plus 3 over 10 plus 4 over 10 plus 2 over 10. Since these are similar fractions, you just have to add the numerator. That's 1 plus 3 plus 4 plus 2, that's 10. So you have 10 over 10 or 1. Okay, so this time let's compute for the mean for this example. So you'll have mu, or mean, is equal to 0 times 1 over 10 plus, you'll have 1 times 3 over 10 plus 2, the next value with its probability, 4 over 10, and then lastly plus 3 times 2 over 10. After that, we multiply. You'll have 0 times 1 over 10, that's 0. 1 times 3 over 10 is 3 over 10, plus 2 over 4 is 8 over 10. Okay, plus 3 times 2 over 10, you'll get 6 over 10. And then add them together, you'll have 0 plus 3 over 10 plus 8 over 10 plus 6 over 10. That's 3 plus 8 plus 6. You will get 17. So you have 17 over 10. This is in decimal equivalent to 1.7. So 17 over 10 is 1.7. So 1.7 is the mean of this probability distribution. Alright? Let's have another example, our last example. Okay, example number 3. Random variable x with its possible values 1, 2, 3, 4, and 5 together with its associated probabilities. Let's check if this is a correct probability distribution. 0.12 plus 0.16 plus 0.25 plus 0.10 plus 0.21 plus 0.16. The sum is 1. So this is correct. Okay, let's try computing its mean. So you'll have mu is equal to 1 times 0.12 plus 2 times 0.16 plus 3 times 0.25 plus 4 times 0.10 plus, next you'll have 5 times 0.21, and lastly plus 6 times 0.16. You may use your calculator to directly calculate everything, or you may do it individually. So let's just show it individually. So you'll have 1 times 0.12 is 0.12, and then next 2 times 0.16 is 0.32 plus 3 times 0.25, you'll get 0.75 plus 4 times 0.10, you'll get 0.4, correct. Then plus the next one, 5 times 0.21, you'll get 1.05, and lastly 6 times 0.16 is 0.96. Then we will add them together. 0.12 plus 0.32 plus 0.75 plus 0.4 plus 1.05 plus 0.96. You will get a sum of 3.6. So the mean of this discrete probability distribution is 3.6. So that's very easy. Again, to compute for the mean, you just have to multiply the value with its probability, all of these, and then add all the product, and you will get the mean. Okay, we are done discussing on how to compute the mean of a discrete probability distribution. This time we will have the variance and standard deviation. The variance and standard deviation formulas are actually related, and it's easy to compute the standard deviation once you have your variance. So you have variance is equal to, the symbol is sigma squared. Again, the symbol for variance is lowercase sigma and then with the square, with the formula of summation of the product of x squared times p of x minus the square of the mean. So again, summation of the product of x squared plus p of x minus the square of the mean. So we have to multiply first. We'll have to square first the value and then multiply to its probability. So we'll write it here is equal to, so you'll have 1 squared, we have it here, 1 squared times 0.46, and then plus you'll have 2 squared times the probability of 0.21, and then plus 3, we'll square it, times 0.33. We'll enclose it, minus the formula, minus mu squared. So we have here the mean, 1.87, and we will square it. Okay, next we'll have to evaluate this first. You'll get 1 squared is 1, so we'll do it individually, plus 2 squared is 4.21, plus 3 squared is 9 times 0.33, and then minus 1.87 squared. You can use your calculator to compute. You'll get 3.4969. And then let's compute it. 1 times 0.46, that's 0.46. Next, 4 times 0.21, you'll get 0.84. Then plus 9 times 0.33, you'll get 2.97 minus 3.4969. And lastly, add these values, you'll get 4.27. So you have 4.27 minus 3.4969. Subtract. Okay, let me adjust. Subtract 4.27 and 3.4969, you'll get 0.7731. So this is your variance, 0.7731. It tells us how wide or spread the distribution is away from the mean. This time we'll have the standard deviation, since variance and standard deviation are related to each other. If variance is sigma squared, standard deviation is just sigma, lowercase sigma. So if we have sigma squared of 0.7731, you just need to take its square root. If you take its square root, then you will get your standard deviation, square root of 0.7731. Use your calculator because we cannot do it manually. That's right. You'll get 0.88, approximately 0.88. Let me check if it's correct. Let me show. Okay, square root of 0.7731, answer. That's around 0.8792610534, approximately 0.88. So we have our standard deviation of 0.88. Our variance is 0.7731 and our mean 1.87. So again, to find standard deviation, you just need to square root. Take the square root of your variance. That is square root of 0.7731. Calculator will give you 0.88. So that's example number 1. Let's proceed to another example. Let's go back to our example number 2. We have here, okay, example number 2 with this distribution. Our probabilities is in fraction. So we'll compute variance is equal to, we'll have to square first the value and then multiply it to the probability. So that is 0 squared times 1 over 10 plus 1 squared times 3 over 10 plus 2 squared times 4 over 10 plus 3 squared, multiply it with its probability, that's 2 over 10, bracket, minus the mean. Let me use 1.7 or 17 over 10, and then square. So let's evaluate. 0 squared is 0 times 1 over 10, you'll get 0. 1 squared is 1. 1 times 3 over 10 is 3 over 10. So let's write 3 over 10. Plus 2 squared. 2 squared is 4. 4 times 4 over 10, you'll get 16 over 10. Plus the last one, 9 squared is, 3 squared is 9 times 2 over 10. So that's 9 times 2, 18. So you have 18 over 10 minus 17 over 10 squared will give us 289 over 100. And then let's add it. 3 plus 16 plus 18, you'll get 37. So 37 over 10 minus the square of the mean, that's 289 over 100. You'll get, you can use your calculator to calculate this one. 37 over 10 minus 289 over 100, you will get 37 over 10 minus 289 over 100. Okay, I'm showing it to you. It's equal to 81 over 100. So we have 81 over 100. This is equivalent to 0.81. So our variance is 0.81. Let's get our standard deviation. So our standard deviation is square root of 0.81. We'll use our calculator. Again, square root of 0.81. You'll have an answer of 9 over 10 or 0.9. So the standard deviation for this example is 0.9. So you have mean of 17 over 10 or 1.7. The variance is 0.81 and the standard deviation is 0.9. So that's example number 2. And lastly, let's go back to our last example. Example number 3. We have here our probability distribution, and we have a lot of values. Though we have a lot of values, but the procedure of computing the mean, standard deviation, as well as the variance is just the same. So you'll just have to follow the procedure and then you'll get your answer. So we'll start. sigma squared, that's variance. Again, variance, sigma with a square. To get the variance, again, let us repeat, 1 squared, the value squared, times its probability, it's 0.12, plus, this will belong 2 squared times 0.16 plus 3 squared times 0.25 plus, it's 4 squared times 0.10 plus, okay, let me adjust, plus 5 squared times 0.21 plus, what's this, 6 squared times 0.16. Okay, adjust, we lock some space. Okay, this one. So we're not done yet for this line. We still have minus, okay, minus the mean, which is 3.6, but we have to square it. Okay, so that's our variance. We just have to simplify this one and we'll have our answer in a while. So let's continue. Variance squared, no, sigma squared, I mean, is 1 squared times 0.12. You will get 0.12. And 2 squared, that's 4. 4 times 0.16, you'll get 0.64 plus 3 squared, that's 9. 9 times 0.25, you have 2.25 plus 4 squared, that's 16. 16 times 0.10 is 1.6. And 5 squared, 25 times 0.21, you will get 5.25. And lastly, 6 squared, that is 36 times 0.16, you'll get 5.76 minus, where was it? Okay, minus the mean squared, that's 3.6 squared, it's equal to 12.96. After this, you just have to add it. Okay, add it all, you'll get 0.12 plus 0.64 plus 2.25 plus 1.6 plus 5.25 plus 5.76, you'll get 15.62 minus our squared mean, which is 12.96. Subtract 15.62 minus 12.96, we'll get a difference of 2.66. Okay, so 2.66 is our variance. Moving forward, to get for the standard deviation, we'll have to just take the square root of 2.66 and our answer would be approximately 1.63. Let's check if that's correct. Square root of 2.66, the answer is this one, approximately 1.63. Okay, so that's correct. So our mean 3.6, our variance 2.66, and standard deviation 1.63. Again, 3.6, this is our mean, denoted by this mu. 2.66 is our variance. And lastly, 1.63 is our standard deviation. So that's it for this meeting. I hope that you have learned how to compute mean, variance, standard deviation of a discrete probability distribution. I hope you have learned something, and thank you. Have a good day.